Alright, another draft physics video presentation and such. Yeah, I'm recording. Okay, sorry. It's always it's a little bit of technology here, gotta get through. Anyway, so still on the subject of the living force. I'll have to go over some stuff redundantly, no doubt. What I think I will do is, just like we're having $2,000 challenge for just playing my 17-minute 2-slit video on a channel with 100,000 subscribers, maybe we can have a bet, okay, with all the physicists who defend this garbage physics, okay, and you can put up money and I'll, reciprocate, up to say $2,000 worth, and we can come up with an experiment that will prove that you're full of shit, okay? So we'll just have to come up with an experiment that we can all agree on, that will prove it one way or the other, okay? So the simple premise to be argued is I'm saying that a 10-pound thing going 10 miles an hour has exactly the same amount of energy, total energy, whatever energy would be called, capacity to do work, force, it doesn't matter what you want to call it, okay, ability to change the universe, as a object that weighs 5 pounds and is going 20 miles an hour. That those two things are perfectly equivalent in how much energy, little bits of energy, volume of energy, capacity they have collected, okay, and contain. And then if we throw them at something like a scale, some kind of spring, some kind of object that can sort of reliably measure how much capacity they have to dent the universe, total ability to move electrons and protons, then it will be proven that they will both dent the universe. If we find a good test instrument, their weight will be exactly the same. If I threw them at a scale, they would measure exactly the same 100, okay? Now their formula says that kinetic energy, or real energy now, is this 1/2 m, okay, and then v squared. So instead of just mass times velocity, which works just fine, and it was a very sensible understanding of what something's capacity, momentum. I mean, momentum, there's just no way to say that isn't energy. Momentum is energy. It is what you contain, what you have collected. Anyway, so this is what they say the formula is, and their results is that this has, what were the numbers? 500 energy units, and this one only has 250. So somehow wrong way, right? The light object has 500 units of energy, and the heavy object only has 250. Alright, so they think this object is twice, okay? Twice as much energy is in it. It possesses twice as much capacity to do work. It has twice as much force. It's twice. It does not equal this. Alright, and so that will be the challenge. We'll come up with an experiment where we take two things of some kind of mass and we'll throw that at some kind of scale. All you need is a regular tippy scale. You could understand this pretty simple. We make a little scale, okay, and then we throw these two things at the same time at the scale, and what do we think is going to happen? I think the scale is going to do absolutely nothing, because it's going to say you hit me with whatever, 18 units of energy there and 18 units there, and that's all I know. And so if we come up with that good measuring device, obviously clay is a crappy measuring device, and that's where this whole thing started, was one crappy experiment. Because obviously everybody knows from their personal experience, if I take a slow-moving object and hit it into clay, the clay deforms, has lots of time to deform. It deforms in all kinds of ways. And if I shoot something fast, like a bullet through clay, well, it makes a nice, perfect little hole, okay? It doesn't deform at all, barely at all. All right, it just sits there and makes a nice little clean hole. So we know we reduce friction in clay based on with velocity. And we know that works on the ground too, because gravity pushes, and more atoms get smashed into the ground, the surface area. We know friction is not a very good way to measure its actual weight, because you're pulling it off so slowly. Friction is a very slow way. It's like a very slow scale. having a scale that can't measure things right away, it's going to get all kinds of different numbers because of deformations and all kinds of different things. So it's not going to give you an accurate measurement. Friction doesn't tell you the truth. Okay, it's not some perfect constant. And the same thing is true with even using gravity, because gravity is the same truth as the truth, right? It's always the same speed. It doesn't matter. And so the heavy object is going to get hit by more force opposing it, okay? Even though it's the same constant of force, it's a constant based on the number of atoms you have. So if you have 4 atoms, for example, and you're in gravity, and you only have 1 atom over here, well, the 1 atom can only collect 1 unit of momentum, one unit of energy. This can collect 4 units of energy. It's going to have 4 units of energy. So obviously as it falls down, this is going to become 8, and it's going to become 16, and this is going to become 2 and 4. And so of course this thing's going to have twice as much momentum when it hits the ground as the thing, well, it's going to have 4 times if it's 4 units more of mass. It's collecting more force. It's collecting more rain. You can just think of it that simply. Gravity is like rain. Okay, if you have more mass, you have a bigger umbrella, you catch more. You catch more energy. And when you hit the ground, all the ground's going to care about is how much energy do you have. You could like shape these things as a point, and so you'd have exactly the same impact and measure it. This is the same. Look, I've made this argument before. I could throw a basketball at you, regular vigorously. Or I could shape the basketball, the mass, into an arrow. Which one do you think you're going to be able to catch? Which one do you think's maybe going to kill you? Oh yeah, that's right. I point you the same amount of air, the same energy. I put it in a form, where I've pointed it, and of course it can do more damage. Damage isn't what we're talking about. We're talking about what's the total energy. And the fact is it'll have the arrow and the basketball thrown aggressively will have the same energy. The bullet has the same energy as the elephant's ass when it hits the balloon that it's the ball it's going to sit on. This is just a fact. I can take a bowling ball, right? I mean, there's so many examples. Now, the fact is there's probably an example somewhere on the internet, and somebody could find that, well, they could save us an awful lot of trouble, where they actually do these experiments honestly. They always bang heavy things into light. They always do it to their advantage. They never do the experiment to completely in terms of when they're ever explaining this law, because yeah, you can do the experiment to your advantage. I mean, the cheat of Physics Girl's video was just so egregious, though, to say momentum was conserved and then say kinetic energy wasn't. That is so insane that even these people arguing with me should say, well, that's impossible. You can't conserve the momentum. That is, you can't transfer all of the momentum from one object to another object and then say you lost half the kinetic energy. They should all be able to admit that's ludicrous. So anyway, the example of a bowling ball, and a bullet. I mean, let's just say a bullet. So I fire it with the same charge. I use the same explosion. Same amount of charge going through a pipe, whatever. So I impose on both of them the same number of little force bits, 18 joules or whatever it is. You do know that, I can change the speed of the bullet, but it's not going to, there's not going to be, in here, there's not going to be 600 times more energy in this bullet than in this bowling ball. And you certainly know the bullet's not going to make the bowling ball go the opposite direction. I mean, you can figure this out logically, that the bullet goes inside the ball. Okay, let's say we make it soft so it can go inside, so all of the energy gets absorbed. Well, if I have the same number of units of momentum, that this isn't going to go anywhere. The ball's going to stop rolling this way, the bullet's going to stop going this way, and the whole experiment's going to stop right here, because it's an equal amount of energy on both sides of the equation. All right, and then I could speed the bullet up a little more, give it more momentum, give it 20 units, and then I know that, well, now the bowling ball is going to roll this way a little bit. And that's true with human beings. If I run towards you and you shoot me, because of my huge mass, the bullet's not going to throw me backwards. Now, if I'm standing still, well then, yeah, I'll go backwards. But if I'm moving against the force, I'm going to have so much more momentum than the bullet. My mass is so big that I'm going to overcome. Even though the bullet's going to kill me, I'm still going to fall forward if I'm moving forward. I mean, you people have to know this. Oh, anyway, that's the context for this nonsense. But let's put real money on it. If we have to do the experiment, look, you have no evidence to show me, okay? You people aren't going to show me a single evidence of this formula being correct, where they actually do a nice clinical experiment and show that the object that weighs half as much going twice as fast, okay, that object has twice as much energy. You're not going to show me that, okay? There's no experiment on the internet showing that to be a truth. So don't blame me for saying, well, you haven't proven it. Well, you haven't proven it. Okay, so I'm just saying we're stuck with no evidence, apparently. Nobody's ever done the experiment correctly. I mean, you can show me clay or you can show me some stupid experiment, but we know, again, how you capture the energy, how you capture it is very important. If you capture it by deforming things, then you're not going to be able to see, okay? But we know a spring is really reliable, so we should be able to come up with some kind of simple experiment with a spring in the middle. You know, I just put a spring here, and then I drop two balls. You know, the fact is they're going to end up with the same velocity, which kind of, you're going to have to throw one of them. The lighter one's going to have to be pushed because it can't move faster from gravity. But clearly we should be able to, and then we can figure out that the spring doesn't go this way or that way. I mean, right now I can tell you there is a crappy video. I mean, I could play it again, where a guy has a Newton's cradle with one ball that's half the size. And you drop the one that's half the size and it makes the ball fly, the heavy ball flies off at the other end, but it doesn't go nearly as high. That's showing you the transfer to the heavier object. And then when the heavy object comes back down, the little ball flies off, but it can only fly off as fast as the ball that's going down. And the second ball also moves, which is indicating not only did it have enough energy to push this one at the same speed it was going, it had energy left over and actually moved the second ball a distance. So it's clear, okay, that the energy was equal, and you're just adding up the masses and the velocities. Mass and velocity is all there is. There isn't any other way to look at it. Mass is just as important as velocity. The mass wears the velocity. Without the mass, you don't have velocity. Velocity can't mean anything without the mass. And they're equally, proportionally equal. You can just change the numbers any way you like. And the fact is they're reciprocal. Try again. But this really shouldn't be an argument with reason. So it just shows how unreasonable. There's just no way physics can be fixed, because these people are belligerently stupid and belligerently obnoxious. They just have no interest in the truth at all. Okay, so Dismal says, well, let me do Jerry first. So Jerry Hall, whatever. Kinetic energy is basically describing how long a distance an object will travel before it stops. I mean, you don't even know how stupid that is. You don't know how stupid that is, right? Because the only way, theoretically, we're talking about, Newtonian mechanics, which often are taking place in vacuums and in places where there is no friction. I mean, that's where these equations are built out of. Okay, when he wrote, F equals ma, he wasn't talking about F equals ma on a railroad track or, rolling ping pong balls or no, he's talking about in perfect circumstances. So there is no how far you travel. The only way you cannot travel forever is something has to be, you have to put friction in somewhere. So what's your friction component, right? If I roll two things across, a heavy thing and a light thing across the ground, obviously there's a huge advantage for the light thing, because the heavy thing, frankly, is collecting more force from gravity. It has more mass, it's collecting more force, it's pushing into the ground further. Obviously, more friction. Okay, so obviously the fast thing, the little thing, the light thing has the advantage again. You keep not recognizing you can't do the experiment that way. So again, we're right back to the whole girly physics thing, where the girl did some clay experiment. Well, she heard about some scientist who did clay experiments, right? And the clay says, and that's what changed physics. If it wasn't for these stupid clay experiments, we wouldn't be having this conversation. It's because you don't understand that you can't apply a force that's uneven, in terms of how you're extracting the force. If you're extracting the energy by measuring how well it plows through a medium, well, then we have to talk about, well, what shape is it? How much surface area is contacting the surface? If all the atoms don't have an equal chance to hit the surface, then, it's like if you're going to put wheels on a cart, right? If you're going to measure with wheels on a cart, well, you have to give this heavy thing just as many wheels per pound as you give the smaller thing. So you can't put them on 4 wheels each. No, if one thing weighs 10 times as much, you got to put 10 times the number of wheels on. So I won't even bother reading this because again, it's just the same crap all over again. Well, anyway, with the velocity v on the y-axis and time on the x-axis, you get a graph like a rectangle with a diagonal cutting through it halfway. Completely dependent on how you're applying your friction. You can't slow things down without applying friction, and friction is just so fudgy in terms of how you can apply it. Whether you're creating a vacuum, between the two surfaces, all kinds of things to change how much friction you have. The friction coefficient couldn't be more unreliable. So yeah, I'm not even going to bother. It's the same bullshit. Okay, F equals ma. Again, so this is another thing. They take this F equals ma as if Newton said that outside the context of describing gravitational force. F equals ma was completely embedded in his gravitational theory. Okay, so let's understand, he's just pointing out that the amount of force is proportional to the mass times acceleration, but he could have said force times mass times velocity, because guess what? Your velocity and your acceleration are, in some senses, well, I can't say they're proportional. Obviously, what you end up with after acceleration is your velocity. So you can't really tear the two things apart in the sense that both things are going to accelerate at the same rate. A heavy thing and a light thing accelerate at the same rate. But obviously the one that's heavy is collecting a lot more energy. The heavy thing, when it hits the ground, is going to make a much bigger hole than this light thing falling. So let's not forget that, yes, the hammer and the feather fall at the same rate, but they have collected a completely different amount of energy. The heavy thing has collected millions of atoms more umbrella. It's collected a lot more energy, exactly proportional to its extra mass. It has collected extra energy. So when it hits the ground, they're not going to both have 18 units of energy. The hammer has collected a lot more units of energy because it has more atoms to collect it with. Oh, God, you people are so stupid. Well, anyway, blah, 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 blah. It's just stupid. Okay, it's bullshit. Absolute bullshit. So no experiment there, no link to any experiment there, indicating the existence of any of this crap. Okay. Damn, so annoying. Alright, so this Dimmel moron. So again, zero experiment. Same to you. Of what you are saying. Same to you. Only bullshit on your board. Same to you. You have nothing. Same to you. Except from your board, non-real experiments, so no real physics, as you said. So no sensible punctuation and clearly not very articulate. And he posts 17 comments, well, 5 or 6 on one video, which I find really offensive, and I'm deleting them as I read them. Alright, we'll save this mathematical. This is just the same bullshit, okay? So I just did Jerry, who doesn't understand that you can't do this based on, well, I'm going to slowly extract the energy over a distance by, tapping it with a Tweety bird. And I'll count how many Tweety birds it takes to slow it down or something. That's not how you extract the energy. So if you're going to use friction to extract energy, yeah, fast things will end up having an advantage. In most cases where you're using gravity to define how much friction there is. Okay. So then he says, they decide to put 1/2 in front of it. Yeah, it's called integration. No, I'll show how it has absolutely nothing to do with integration. So again, you don't know the history. You don't pay any attention to the truth. Visa, from the Latin word living force, is a historical term used used for the first known description of what we now call kinetic energy in the early formation of the principle of the conservation of energy. Proposed by Gottfried Leibniz over a period of 1676 to 1689, the theory was controversial as it seemed to oppose the theory of conservation of momentum advocated by Newton and Descartes. The two theories are now understood to be complementary, and they can't be understood to be complementary. Physics Girl just pointed out how they're not at all complementary. How the fuck can they be complementary? I 100% transferred the energy, the momentum. 100% transfer of the momentum from one object to another object. 100% of the momentum transferred. Yet I lost half the kinetic energy. Pile of shit. Impossible. Any physicist would say that is truly impossible. You can't possibly transfer all of the momentum and lose half the energy. It's not possible. Anyway, so clearly, and the first version of it had no half in front of it, okay? Integral, blah, blah, mv squared. That's all. Just mv squared. The first version of the formula didn't even have the half in it. So don't tell me it was a derivative of anything. It was just squaring the velocity. And it was way off, okay? So instead of it being 500 to 250, it was now 1,000 to 250. So it was even more off as an experiment, as a description of real energy. Liar. Okay, so let's just keep doing this. Obviously, the integration bullshit was what the mathematicians did in the 1800s to fix it. Okay, so they found a contrivance. But it has nothing to do with being on it. This is a version of Newton's theory. No, this is not Newton's fault. So this is just like when they blame Einstein for gravitational waves and blame Einstein for all this other horse shit and say Einstein invented entanglement. No, he was opposed to entanglement. Directly, overtly. You know, and they'll say he invented it. Yeah. Disgusting. Newton would not like this at all. As I stated, I'm quite certain when Newton looked at the universe, that's all he saw was mass and velocity. And he didn't see them as completely unequal partners. All right. All right. The human race becomes stupid. Let's see. Yeah, it's called integration. The human race has become so stupid. Yes, and you are the proof of that. So again, let's put your money where your mouth is. All right? And let's do the experiment clean, get it done, okay? Have it just sit there and say, go ahead, explain this. Explain how this equal sign doesn't belong there. That you can have two things that have exactly the same momentum and you can claim they have different energies. Show me those two things that have the same exact momentum and yet you're going to claim they have different energies. Also about acceleration, did not say anything at all because you obviously, I know I said plenty about it, did not show the relationship that tells you that acceleration is a derivative of velocity. So they keep saying acceleration is a derivative of velocity when it isn't. You can accelerate things in very different ways with very different mechanisms. And even if I said we never have deformation and we never have any way that the acceleration is diluted through deformation, even if we had a perfect world, okay, the point is that to accelerate two different masses, you need more force. They think F equals ma. They think that means the same force is always at play. Like it's a gravitational force and therefore the same amount of force is being applied. Gravity is the same for every atom. It's not the same, okay, for different objects of different masses. If you have more mass, you have more collecting. You collect more force. More force acts on the hammer. Yes, the hammer and the feather fall at the same rate, but much more force acted on the hammer. It collected, it obstructed, it banged into. Much more force. That's why it has more momentum, because it collected more from the same amount of force, the same rate of force. And the rate that the force is collected is decided by your mass. Oh, God, people are so stupid. All right. Also, about acceleration, Obviously show relationship potential. Okay, we already did that. Tells you that the acceleration is the derivative of a velocity. Again, I didn't ignore it. I'm ignoring the fact that you don't seem to really understand what energy is. And again, that force equation based on acceleration isn't really telling you how much force it took to accelerate something, right? So if I just say acceleration is the same because they move the same distance, you do understand that if I move two things the same amount of distance in the same amount of time, it didn't mean I had to apply the same amount of force. You do understand that that's why your derivative is a piece of shit. You're implying that I can push a 10-pound weight with exactly the same amount of force as a 1-pound weight. That if I was pushing on them and moving them a certain distance in a certain amount of time, that somehow I would apply the same amount of force. When you know the answer is, no, you wouldn't. Okay. Let's see. Ignored it because obviously benefits you, and of course you can't understand what a derivative is. I think it's dangerous, as I pointed out earlier. It's very dangerous to take different formulas created in different contexts and then say, well, I'm going to take this thing and say it equals this thing. So that's what gets you in trouble with the whole, light thing. You know, where you say wavelength and frequency are inverted, and you do, what's the more clear example? But you end up saying that energy is frequency when it really isn't. But anyway. Also, the experiment I sent you, there was no experiment you sent me that's relevant to this scenario. That's comparing two objects of different masses or different velocities and deciding how much energy they have. So until you show me an experiment that has something to do with this conversion of the total energy of an object that have two different, that you say have different kinetic energies, that's what we want. I already understand the principle of conservation. Again, in the physics girl experiment, will you explain this? An object hits another object, and it transfers all of the energy. That is, object A, let's say it weighed 10 pounds, and it was going 10 miles an hour. It hits a train, and it transferred all of the momentum. Perfect transfer of momentum. And you're saying, though, that all I have to do is change those weights a little. So she had the lighter object hits into the bigger object. Okay, so the lighter object's going 10 miles an hour. The heavier object now goes 5 miles an hour. Perfect transfer of momentum. That's the fact of the experiment. There was a perfect transfer. You can't be going 5 miles an hour unless you transferred it perfectly. 10 miles got converted into 5 miles on half the mass. Perfect transfer of momentum, and yet half the kinetic energy was lost. You can't explain how that makes any sense. It's impossible for it to make any sense. It's absolutely nonsense unless you want to say momentum is a complete lie. We should abolish the word. Momentum means nothing. It has nothing to do with the truth. That's the only way that can make sense. And the day you do that, then you break all celestial mechanics, and you'll never do. Well, you already are there, right? You're already there. You already can't make anything make any sense. That's why you have to invent dark matter and the rest of it, because you're using the wrong fucking formulas, morons. Anyway, let's see. Of course, you can't understand what a derivative is. Yeah, I understand what it is. I understand it's a little bit dangerous. You got to be careful. Again, you are too idiot for that. Also, the experiment I sent you to see the first one where it clearly shows the principle of conservation of energy, which is 100% valid and shows that the correct type of kinetic energy is mv squared. Bullshit. 1/2 mv squared. So again, just absolute nonsense. I'm certain the experiment had absolutely nothing to do with taking an actual measurement of actual energy. All they were doing was saying we have certain amount here. Whether you calculate it with 1/2 mv squared and get a wrong number in, wrong number out. So I'll just say to you, I could do exactly the same experiment using momentum as the equation. And as long as I use momentum going in and momentum going out, I'll bet my answer it'll come out exactly the same. So that's just a bullshit argument. Yes, you use the wrong formula in, you'll get the wrong formula out, you'll make the same errors on both sides, so it won't matter. Okay, so we can agree on that. I'm just saying I could just replace my formula with their formula. We'll just say, I'll say 100 joules, they'll say 500 joules. It really won't matter because no one's going to measure the actual joules. And we'll just say, oh yeah, we transferred 500 from here to here, fine. I call it 100 from here to here, fine. So this had nothing to do with the experiment, it has nothing to do with the argument. Yes, 1/2 mv squared can work if you're never really measuring the joules. If it doesn't really matter what the total energy is, it'll work because you don't care about the number, you just care about moving the number through other formulas. You're trying to figure out something other than its actual energy. Then this formula could be harmless because you don't care about the explicit truth. What I have shown you about the pendulum, okay, you didn't show anything about the pendulum, so that's just a crazy lie. Again, just has absolutely nothing. That stupid mathematics has absolutely... I could go right to that fucking equation that jackass did on his fucking board. I'm going to call him a jackass because his physics sucks. Okay, Van Briesen. I could go right back to that board and erase every part where he has the mv squared crap in it, and I could just replace it with mv. And it will change absolutely nothing because he's just measuring a fucking formula going one way and then the same thing going back the other way. He never measures the actual joules of the pendulum, you stinking lying sack of shit. God, you're so fucking dumb. Alright. Pendulum uses only energies and ends up with exactly the same result as Newton's second law. It would end up with exactly the same result if he just used MV. MV in, MV out, it would be harmless. So what, you want me to have to actually prove it and erase his board and show you that you'd get exactly the same answer. All you're doing is measuring MV going into gravity, MV coming out of gravity. Obviously, that's not going to make any difference. Both formulas will say the same thing when you're just going up and then you go back down again, using the same formula. Obviously, nothing's going to change. But if you want to know the actual energy, you want to get the right answer, you have to use the right formula. It is obviously that if the formula for kinetic energy was wrong, it could not do that. Of course, it's obvious that it could do that because you're using the wrong formula going up, measuring its energy, and then you use the same wrong formula going down. How is using the wrong formula going to change anything if you use it both going into gravity and then you use it going out of gravity again? Obviously, it can't change anything, jackass. So it is obvious. No, it isn't obvious. It's obvious to me that you really just don't give a fuck about the truth. That from the moment it ends up in exactly the same equation, the formula for kinetic energy cannot be wrong. So I guess he can't figure out that if I use the wrong formula going up and I use the wrong formula going down, then I'm likely to get the right answer anyway if I'm measuring something else. If I'm just trying to see it, is there an equivalency? It doesn't matter whether I have the wrong answer. I could say it's 500 joules going up. As long as I'm measuring the same way going down, I could say, yeah, it doesn't matter if I have the right answer or the wrong answer. So it's just bullshit to say that fucking formula proved anything. It clearly wasn't an experiment. It clearly wasn't anything that had real numbers in it. Also, I have not seen any of your experiments. If your physics is as correct as you say, why cannot find a single experiment to confirm it? Yeah, and I'm asking you to do the same thing. Show me one single experiment where the objects with the same momentum but different masses, so they have exactly the same momentum but they have different masses, you show me how one of them makes light bulbs burn longer. You show me the one that generates more electricity. You show me, the wide stream going slower versus this narrow stream going faster. Show me how one of them makes more energy than the other. Ignoring mass and velocity. There's only mass and velocity, and they're equal components, period. That's the Newton's truth. It was true when Newton wrote it down. It was true a billion years before Newton wrote it down, and it's going to be true a billion years after Newton wrote it down. Those are the two components. Mass collects the energy. All right. Also, I have not seen, likewise, I haven't seen any of your experiments. Is as correct as you say. Why? I have seen the clay experiment. So are you arguing that clay is a very good way of collecting energy? That clay doesn't like obviously deform all over the place? So you're not you don't even accept the argument that clay, how far something penetrates clay, is not a good way to measure energy. You concede that point or not concede that point? All right. Also, I have not seen any of your experiments. If your physics is as correct as you say, why you cannot find a single experiment to confirm it? Like I said, because physics doesn't want to prove itself wrong, I guess it would say would be one obvious answer, but it probably is there. There's probably a video of two trains hitting each other. I think there actually is a video from like 1919 of two trains crashing right into each other, the same speed, and they go right up in the air and then right down. Right? Now your theory is that if I take the heavy train and I take the light train, I crash them into each other, and all the energy has to go this way, right? Because they're on a track and they're going to crash into each other. Your argument is the light thing has so much more energy, twice as much energy, and it's going to push the heavy train. All right. Single experiment to confirm it. And why is it so difficult for you? And the only thing you can do is write bullshit on your board. Well, whatever. You're the one writing bullshit. I'm the one telling the truth. The truth is, this is not Newton's formula as you suggested. It was in fact contrived by his greatest enemy in life, Leibniz, who stole his calculus from Newton's own perception. Clearly Newton believed he stole it. So what's this argument about again? Yeah, the clean physics. No, this isn't clean physics. This is garbage soap opera physics. All right, I will answer first. Okay, that's the math thing, so let's do the other ones first. Why don't you try to hit your head some more times? Maybe this will make you less stupid. Yeah. I can, what do you want me to do? I'll just gratuitously insult you for having a small penis. Obviously, you have a very, very small penis. And this is a silly way to try to overcome it. It's really not working. I mean, I can see it from here. Okay. I would like to see your solution to the equation which confirms that the compression will be the same as you say, or even an experiment. So again, the experiments are kind of obvious. I mean, you jump on a scale, right? If I just stand on a table and jump on a scale, the scale will say I weigh 800 pounds. Why is it saying I weigh 800 pounds when I don't weigh 800 pounds? Well, that's right, because it's my momentum that it's measuring. And momentum is energy. I am collecting energy as I'm falling, okay, and my momentum number is increasing and increasing. As I'm falling, I'm gaining more and more momentum. Momentum is a really good way to describe what energy is. Energy, momentum equals energy. It is that obvious. All right, experiment, but obviously you cannot solve equations. So again, this is about the fact that the equation itself is incoherent. And it started off completely incoherent. It started off with some asshole just saying velocity seems to be really important. It looks like it's alive. The bullet is alive with energy. Living force. That's what they called it. It's alive with special energy because it's going fast. Fast things have special energy. Woo, 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 woo. You're just so full of shit. All right, wait. And you don't have experiments that confirm what you say. I'm saying there's probably, okay, they probably are out there. Somebody dropped stuff into water or some other medium that's not quite as prejudiced as clay and found no extra displacement. That the displacement of total volume of water is exactly the same, whether I change the mass or I change the velocity. Whatever relationship I use, as long as the momentum is the same, I'll get the same impact in terms of real energy hitting the water, displacing the water. All right. So, like I said, if somebody wants to find the experiment, just how do you even search for it, right? Because physics is so myopic and so closed-minded. How do I even search for that experiment? I mean, what keywords do I use? Because there isn't going to be some experiment like I could go to the physics girl's video, right? And she tells me what the truth is. She tells me that I conserved momentum, but I destroyed twice, half the kinetic energy was lost. And if she would have done the experiment the opposite way, that is hitting a light thing into a heavy thing, a heavy thing into a light thing, she would have said, we gained, we have the same momentum, but guess what? We gained twice as much energy. We got free energy. So it's just how you do the experiment. If you just reverse the role, you don't lose half the kinetic energy. Somehow you magically gained kinetic energy. So I can just bang heavy things into light things, and I can gain kinetic energy all day long. I can just make free energy. All right. I will answer first is not what I believe. Let's see what Newton's second law says about the subject. Again, Newton's second law was written in the context of gravity, obviously. And he was talking about the fact that the mass, that's why the m is there, the mass, all right, is half the component of what you're going to gain in terms of force. As you're collecting force based on acceleration. So the acceleration is going to be the same. But if you have more mass, it means more force. So you can almost just take the a off because it's the same for both objects. The real key is not the acceleration, how fast you're moving. Okay, the real key is how much do you weigh? How much force can you collect? How many atoms are collecting energy? How big is your umbrella? How big is your sail? That's going to decide how much energy your boat has. All right. First, Newton's second law, F equals ma, which gives for the mass spring system. So again, I don't think Newton intended this formula to be used in any other context than gravity, because gravity is a consistent accelerator. Gravity accelerates all things based on how many units of mass it has, based on how many electrons and protons it has. And it always gives every electron, every proton exactly the same amount of energy. So you're just saying how much mass does it have, that they'll tell you how much energy it has, because the mass is the collector. So you think this formula was meant for all cases in all places. Bullshit. Which gives the mass spring system. So now we know that the spring has the constant in it is the spring constant. Okay, so this is much more complicated, which is ma plus kx equals 0, which can write as blah blah blah. So again, he's just giving me now another derivative, right, from something that was intended for one context, applying it to another context, and this is the danger of their derivatives. They've established now an equivalency between force and something completely different in terms of what you're measuring. The F isn't one total. The F is a different amount of force depending, like I said, even though the objects are moving at the same speed, one of them is collecting much more force. Alright, so it's just more of this blah 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 blah, and he comes down here and says, implying, okay, so let's put some numbers in. Let's say you have a body with mass of 20 kilograms and initial velocity of 5 meters per second, and then we have the second one is 10 and 10. So we have our two trains. He says when you plow them into a spring, they're going to compress the spring a different amount. Now, do you have an experiment to show that? And then the whole conversation can be over. Because we know the spring is pretty consistent, okay? Springs aren't bad. They're pretty good at collecting energy and then releasing all the energy. They're pretty good, like batteries. They collect energy and then they release energy. All right, so, and they don't care really how fast they release it. They can release the energy very slowly, or they can release the energy fairly quickly. So it almost doesn't matter how light or heavy the object is you compress a spring with. And he's arguing that the spring will be one spring will be compressed 22 centimeters and the other spring will be compressed 31 centimeters. Now, do you have an experiment? Do you have an actual experiment to show that's true? Because then we can just resolve this and say, well, it obviously has more energy because you compress the spring further. So yeah, no, I can't deny it. Okay, it has more energy because it compressed the spring more. So show me that. But you're not going to do it because it doesn't happen. That doesn't work. All right. So Newton's second law says that the compression will not be the same. So he says Newton's second law says that. Obviously, Newton's second law doesn't have anything to do with spring constants or any of that crap. It doesn't have anything to do with these derived formulas. So he's saying that's what Newton said. Obviously, Newton didn't say that. So just another pile of shit lie. Okay, and again, the argument is just, you can see it. I can drop a feather and drop a hammer, and they're going the same speed, but when I'm obviously collected more energy, this is going to make a big giant dent in the ground. Anyway, but momentum is energy. This is just horseshit. So I have responded to your nonsense. Fuck you. Grow a brain and realize that you could just make a physics argument for a change. If you don't want to be insulted, just make a physics argument. If you can manage it. All right. So we'll just read this overview part, and we'll get to most of the key points here. Proposed by Leibniz over a period of blah, blah. The theory was controversial as it seemed to oppose the theory of conservation of momentum advocated by Newton and Descartes. The two theories are now understood to be complementary. Obviously, they can't be complementary unless you're going to say you conserve the kinetic energy or you conserve the momentum. You can't conserve one and destroy the other. If you do, it's impossible. You just can't do that. They can't be complementary because this example of trains of different masses already points out it's not complementary. If I efficiently exchange the momentum, okay, they're going to claim still that somehow I lost a ton of it. And again, they'll never do the experiment the reverse way, because then they would have to explain where they gained kinetic energy. Just because I banged a heavy thing into a light thing, I automatically gained kinetic energy. The theory was eventually absorbed into a modern theory of energy though the term still survives in the context of celestial mechanics through the viva equation. So that doesn't even make any sense. It was absorbed and it still survives. Yeah. I mean, that sentence is stupid. The theory was eventually absorbed into the modern theory of energy, though the term still survives in the context. Oh, so they still use the viva equation. So I guess that's why they can't figure out why the stuff on the outside of the galaxy is moving the wrong speed, is because they're using the wrong equation. Oh, that is funny. All right, the term is due to German, okay, you already told us, who during these dates first attempted a mathematical formulation. Leibniz noticed that in many mechanical systems, several masses m1, each with velocity v1, the quantity mv squared. So again, it wasn't a derivative. It's what he noticed from mechanical systems. So again, he's going based on the fact that velocity seems to have a bias in mechanical systems. A lot of mechanical systems, velocity gets a free ride. So if your momentum is in the form of velocity instead of mass, and especially on the surface of the Earth, this is going to be true. Right? Again, unless you do the experiment to try to equalize the two things to make them elementally the same. So if you're going to have a cart, a four-wheeled cart with two different masses on it, you obviously, if you're going to do it and try to be fair, you have to put 8 wheels on the heavier, the twice as heavy object. Those kind of things to try to make the two things equal. If you don't make them equal, forces like friction, the friction will be much higher for the object that's heavier than for the object that's lighter. That's the obvious cheat. The experiments have to be conducted. You have to arrange the experiment with some logic and sense, or you're going to be fooled in your results because you haven't accounted for the inequity of the how the energy is being extracted. It's like the whole car example. The car having a much harder ability to stop it when you're going faster speeds. Well, that's because you're not making the tires bigger. You're not making the surface contact with the highway bigger. You're using the same size tire, the same size exposure to friction, and expecting the same result at a higher speed. Well, you're not going to get the same result. All right, was conserved. He called this quantity viva, again, or living force, la 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 la. So this is the physics, the religion they're defending. This is the concept that they say, oh, this is highly structured and highly mechanical and this is real science. Living force. That doesn't sound like religion, yet sounds like religion. The principle is now realized represents an accurate statement of the conservation of kinetic energy in elastic conditions. So again, this whole elastic and inelastic thing, all we're saying is that you have to be very careful in how you transfer energy. And with hard objects, you can make some kind of transfers really well. But it's difficult. Say if you're trying to make something go, you're going with the faster object to move the heavier object. It's always a problem because the heavier object to move the faster object. Because the heavy object hits the lighter object and it can't actually make it go faster than it's going. It's really hard to do that. It can only say go as fast as me, because as soon as it starts going the same speed as this, you can sort of understand as soon as this thing starts going the same speed, this thing can't catch up to it anymore and give it more energy. So as soon as it reaches the same speed, this thing can't give it more energy. But what you will see if you roll the heavy thing into the light thing, and what you will see is the light thing goes off and the heavy thing keeps moving too. So you know the heavy thing has more energy to give. It just couldn't give it all to the light thing because it can't fix the problem that it can't. Once it gives it the same velocity it has, it can't give it any more velocity. A guy running 5 miles an hour can't push a car 10 miles an hour. Right? So it's hard for the small thing for the fast thing it's hard for a slow thing to make a thing go faster than it's going. And that's why there's visual problems. But you have to just follow along. Oh look, they're both moving. Yeah, that means this thing still has energy. It didn't transfer all of its momentum. All right, accurate statement. That's just that is so obnoxious, completely inaccurate. But anyway, inelastic and is independent of the conservation of momentum. So again, how can anything be independent of the conservation of momentum? How is it just possible? How can they destroy something as solid as momentum? Momentum always works. It's always real. It's always functional. Show me an experiment where it gives you the wrong answer. So show me one experiment where, momentum gives you the wrong answer. However, many physicists at the time were unaware of this fact. So they say they were unaware and instead were influenced by the prestige of Isaac Newton. So this is so prejudiced, right? So they're saying all the opposing physicists were idiots. So Voltaire was an idiot, or Descartes, or any of these other people. They were just idiots. No, they argued it, and they pointed some of the arguments I'm making, they made. And of course, over time, all of that was lost, and the girly physics won. Anyway, prestige of Isaac. So again, they're just saying they were going with Newton because of his prestige. Not because it worked, not because it made perfect sense. Again, I can't see the universe any other way. I can't look at these objects and go, oh, the mass is only half as important, and the velocity squared. I mean, it's squared, so go fast, and man, you can make energy that way. I can't see the universe that way. All right, both of whom advance the conservation of momentum as a guiding principle. Yeah, it's the definition of energy. That's the principle. Momentum is energy. You don't have momentum unless you have collected energy. You had to collect it from something moving. It conveyed it to you. You absorbed the movement. You possess the energy, and it will be described as your momentum. And it will be derived by simply multiplying your mass times your velocity. Was held by the rival camp to be conserved viva. I don't even know what that means. Was held by to be conserved viva. Be conserved kinetic energy. To be conserved. This momentum was held by the rival camp to be conserved kinetic energy. Yeah, see, even if I replace kinetic energy for this, it doesn't make any sense. It was largely engineers such as, who the hell knows who any of these douchebags are, who objected. Let's see. Samuel Everett Holtzman, Hearn Sigurn, who objected that conservation of momentum alone was not adequate for practical calculations. So again, we have no evidence of how it's not adequate. We have no evidence how it doesn't work. We just have engineers saying things like, well, higher vibrations make things fall apart faster. That doesn't mean there's more energy in them. Just like ultraviolet light makes electrons fly off. Doesn't mean there's more total energy. Just means that they're hitting the thing at its resonant frequency. So again, because something has a frequency which it's likely to break, they're just saying, well, that's automatically more energy. Practical calculation, and then made use of Leibniz's principle. So these are the idiots who ruins physics. The principle is also championed by some chemists such as William Hyde Williamston. Okay, I never even heard of. French mathematician Émilie de Cartelet or whatever. So this is the chick, okay, lots of money, who had a sound grasp of Newtonian mechanics. She did translate Newton's books, so she was, she did a lot of good things for science. They had a fantastic library and all that kind of crap. But this garbage, developed Leibniz's concept and combining it with the observations of William, Gravesand, showed that viva was dependent on the square of the velocities. So again, these are the Clay experiments. So because Clay has a huge bias in terms of deformation to fast things, that it'll yield to fast things, it doesn't yield to slow things. Therefore, we have to invent this fake energy. That's the history. So there's no derivatives here. There's no, this is a mathematical concept. All they did was square the velocity. So the real formula at this point, right now, in this point in the history, the formula for kinetic energy, or living force, was mv squared. No half. Members of the academic establishment, such as John Playfair, were quick to point out that kinetic energy is clearly not conserved. Yeah. Yes, because it's completely inconsistent with momentum, and momentum is. This is obvious to a modern analysis based on the second law of thermodynamics, but in the 18th and 19th centuries, the fate of the lost energy was still unknown. Yes, there is no fate of the lost energy. So this is the lie of physics girl. She says the momentum was conserved, all the momentum was transferred, and then she starts talking about, oh, but there was a lot of deformation, and there was sounds, and there was this, and there was that. Well, the train can't leave at 5 miles an hour if there was deformation and all that. It has to be 4 miles an hour, 3 miles an hour. So if you deform something, then it couldn't leave with the same momentum. It has to lose the momentum. Any deformation, any heat, any sound, anything has to take away from its momentum. Because momentum was the only source of it in the first place. So that's the huge, preposterous lie. I mean, it's so illogical. This is obviously a modern analysis based on the second law of thermodynamics, but in the 18th and 19th centuries, the fate of the lost energy was still unknown. There's no lost energy. So again, it's just too silly. Gradually, it came to be suspected that the heat inevitably generated by motion was another form of living force. So again, if you're creating heat in the transfer, you won't be able to get 5 miles an hour, right? The 10-mile-an-hour train banging into the heavier train, it can't go 5 miles an hour if you created heat. It's not going to leave at 5 miles an hour. So it's all just such a lie. Okay, in 1783. Some Lavoisier and Pierre Laplace reviewed the two competing theories of blah 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 and caloric theory. Count Rumsfeld's 1979 observations of heat generation during the boring of cannons added more weight to the view that mechanical motion could be converted into heat. Well, see, duh. We already know that can happen, but it's no excuse. If you have the same momentum going in as you have going out, you didn't make anything hot. That would be free heat then. This visa now started to be known as energy after the term was first used in that sense by Thomas Young. So here we are back to Thomas Young and the big fake of the double slit experiment. The frickin' Thomas Young experiment was so imprecise and never measured, never done correctly. It couldn't have gotten the right answer. His drawing is completely wrong when he drew it. It won't get the right answer. The point sources can't be in the center of the openings. It's just a big fat pile of shit. Okay, and he's also responsible for playing with this shit also. So it's all about who they made a hero out of in physics. It's all, whoever they made a Bohr, you end up with a Bohr model. You just end up with whatever crap this icon had. And it doesn't really have anything to do with the physics being rational. Or anyway, the recalibration. Okay, so this is where we get to where they stuck the 1/2 in. So just understand, the formula was 100% off. Okay, being half off is that's 100%. It was getting the wrong answer by 100%. Yeah. Okay, the recalibration to include the coefficient of a half, namely, was largely the result of the work of, these are people no one knows, right? Gepard, Gestov, Colodius, and John Victor Poncelet over the period of 1819 to 1839. So this wrong formula, again, was for decades wrong, completely wrong. Okay, whole 100% wrong. And and then they just stuck a half in front of it. So, and that's it. That's it for this. The farmer called it the core, whatever, the work, quality of work. So now they're giving it some other idiotic name. And later travail mechanical work, and both championed its use in engineering calculations. Right, because the engineering calculations don't have anything to do with the truth, I guess. But I'm just saying, it gives you the wrong answers. Isn't that terrible that that's all this article is? But it's right there, okay? So go ahead and lie that this is Newton's formula. Lie that it was created out of a derivative of Newton's formula. No, it was created because people observed certain experiments and said, this experiment looks exciting because it looks like there's 4 times as much energy. They watched a bullet go through a watermelon or whatever, and then they watched, say, a golf ball bounce off the wall, and they said, oh shit, that bullet looks like it has a lot more energy. Even though they had the same amount of energy, right? It's more looks like physics. It looks like, right? That's what Thomas Young was all about. Yeah, it looks kind of like an interference pattern, on off. Yeah, it's the simplest pattern in the universe, but I'll call it interference, right? Because interference is cool and interesting, and scatter, well, yeah, that's boring and uninteresting. I mean, this is just so bad. I'm sorry, you people all should be embarrassed that physics made these kind of colossal mistakes, and you're defending them. This isn't Benjamin Franklin made an honest mistake, and the fact that you never fixed that, something so fundamental, is getting plus and minus, putting them in the wrong place and just screwing everything up, making everything so much more confusing than it should be, and you never fixed it. And then you have this, your fundamental energy formula, and it's a grotesque monster. It's a Frankenstein monster, and here you are trying to, get it married to people. I mean, you're trying to sell it as a good husband. I mean, it's just so bad. You're so evil. God, you just hate the truth so much. I mean, this couldn't be an uglier origin for a physics concept. I mean, coming out of the mouth of a guy who stole Newton's calculus, a real player. Then endorsed by just a bunch of fancy pants people with lots of money. I mean, it's a terrible source of a truth. All right. So I've done all. I mean, Okay, so I'm just saying, I'll put up whatever. You want to go to $4,000? You want to go to $10,000? I mean, I can borrow the money. I got family that'll probably trust me. We'll go ahead and do the experiment. So put your money where your mouth is. Let's do the experiment. Okay, if we have to do it because nobody can find it done anywhere. Your whole physics community has never crashed two unequal, two equal momentum objects and never crashed them into each other. Apparently you never did that. Okay, I think Professor Lewin probably has done. All right? If I go to those sliding cart, the ones where he's pushing carts into each other, maybe one of those he actually puts different masses on them and we could see the results. But you're just silly people. You really think momentum isn't the truth. Momentum isn't telling you real energy. So you know it when the things are hitting the ground. You know the hammer has more momentum. Mass times velocity. You know it has more. And it's completely dependent on its mass. It's not 1/2 of its mass. You know its momentum. You know how big a hole it's going to make in the ground. It's going to be completely decided by its mass. Why are you pretending this half thing works? That you can just sit there and pretend the mass isn't really playing an important role. And the velocity is everything. I just can't. I'm just stunned. Like I said, I never realized humans were this belligerently stupid. I just didn't think people were belligerent. I thought people just made mistakes. They overlooked something. I didn't see that. Didn't catch that. I thought they just made honest mistakes. Clearly, physics, these aren't honest mistakes. These are really dishonest mistakes. And the aggression with which people are attempting to defend this bullshit, it just amazes me. How aggressively they must defend the bullshit. Okay. So, till the next time and such. So forth and whatnot. There's nothing I can do. I can only take care of my end. I'm playing a good game. You people are not. And that's just the truth.